So hi, everyone. I'm a software engineer by trade, but my other big interest is photography. I actually brought my camera here. Can I take a picture with you? Of you, actually. Woo! There you go. So this whole story started with the realization that over the years, I realized that I have accumulated more than 50,000 pictures on my hard drive. So my main collection is on my desktop PC that I barely turn on anymore. And I wanted to have some way to build a small gallery app where I can see the pictures that I have, because I have really nice pictures that I like, but I never get to look at, things like this. So I was sad I never get to look at them, so I was like, I'm a builder. I like to build things, so let's create a simple photo gallery. It would be a simple page that only shows one random picture from my collection, and I can resurface memories and old pictures that have been gathering digital dust over the years. And I really wanted to keep it simple. I did not want one more thing in my life to maintain. I was just very, very simple, basic. So I worked on it for about an afternoon. And at the end, I got something like this, where I got a web page that showed one picture. And I have some metadata here, where I can see the date the picture was taken, the name of the folder, and what camera I used. And I kept it very simple. So this is the gem file. That's it. Time passes, and I got a new laptop. And I wanted to try to work and continue working on the photo gallery. And I go to my laptop, I open the project, bundle install, and yep. Show of hands, who has run into this issue before? Yeah, a couple of people. And whose first reflex was I'm just going to try to Stack Overflow this and copy paste whatever they tell me to do. Yes, that's most people. So yeah, I had so many questions. First of all, what is a native extension? What does this error mean? How can I fix this? And why did it stop working? I didn't have to do anything on my old laptop. So hi, I'm Youssef. I spent an entire weekend debugging this issue, so I'm here so you don't have to do that. My day job is at a company called Workato, where we create a product for businesses to automate their workflows without needing to write any code. I'm part of the developer experience team, where we create internal tools for developers to be more productive. And I think we have the cutest mascot of the whole company. So with this, let's jump into this rabbit hole of native extensions and see what we can find out. So first of all, what is a native extension? So the TLDR is that a native extension is a gem that includes C code. So Ruby is written in C, so you can also, there's a way to call C or C++ code directly from Ruby. And that's what we call a native extension. And if you know C, you know it needs to be compiled. And that happens, in this case, at build time. So when you install a gem that has a native extension, it has C files, and it compiles the C code to a binary that's native to your architecture or your computer, laptop. That's why we call them native extensions. So fun fact, when you write this in Ruby, 99.9% of the time, this will go and look for a Ruby file. But it's possible that this goes to a C file and loads codes from compiled C libraries. So why do we need them? Why do we want to write anything else than Ruby? So the first reason is performance. So when you have some functionality that needs to be really fast, and you want, it's a really tight loop, and your business depends on it, so native extensions were a common way to write really, really fast code. Some examples of C extensions that have that is the JSON. So the default JSON gem is written in C. And the big decimal implementation. So I said where because of all the widget work that has been done. Now, if you write your code in Ruby, it gets saved and cached in C, so it's fast, or if not faster sometimes, than writing in Ruby. So this use case is slowly disappearing. And the second reason why we want to do this is to wrap external libraries. So imagine, for example, like you have this, like Postgres is a good example, where someone has written like the standard implementation of how to connect with Postgres in C, and you don't want to re-implement the whole thing in Ruby. You just want to be able to go and use the C library that people have already written. So yeah, interacting with external systems is really one of the primary use cases for this. Postgres, MySQL, like the Kafka libraries, they're all bindings into these C libraries. You can need it also to parse complex formats where the reference parsing or a parser has been written in C and you don't want to reinvent the wheel. So Nokogiri is one of the really big ones that we use. That it wraps the libxml too. And exif, which is a library that's used to read exif data in pictures, which is what I used. And exif data is when you can save metadata over the picture, like which camera took this and which, like what date was it taken on. And another very fun use case is to interact with hardware. So if you want to interact with USB or Bluetooth directly from Ruby, it needs to go through a layer, and like that layer is mostly written in C. And we go back to the gem file. I wanted to keep it very simple, but I somehow managed to have a native library in there. So 1/3 of my code is native libraries. So now that we know what the native extension is, next question is, how does the C code get into Ruby? So under the hood, what happens is that you have a gem. The gem has literally like Ruby files and C files. And that code gets pulled when you do gem install. And Ruby creates a Makefile. And that Makefile is, uses this xconf.rb file to be created, to be generated. And this is what's been used to compile the C code. And then at the end, we get a .bundle file that is the compiled binary. So I just want to show you an example. This is the exif library that has been causing all of this. And you can see here that there are like actually C and header files. And there's this xconf.rb file that's very important. So the C code is compiled at install time. So it's not when you run your app in production. It's when you run bundle install that the C code gets compiled on your specific computer. And if that compilation fails, then that's what happens. And in order to make more sense of this, we need to fall deeper. So let's talk a little more about C. The C files they have two main extensions. There's the C files and the header files, C and H, that get compiled into object files. So we take these files, we have a compiler, a C compiler that can be configured using the C flags environment variable. And then we generate these object files. And these object files, you can think of them as like exactly this. Like it's a puzzle piece. It's not the whole picture, but it's a part of a picture that you cannot really use yet. And then what do we do with these? So we take these object files. And then we can also take any library that has been installed, like for example, the exif library or the XML library, any C library that we want. And then we pass them through a piece of software. It's called the linker. That's very important in this tool chain. And this linker then puts all the puzzle pieces together to form this last very complete image, which is a bundle file. And the linker can be configured with environment variable called LD flags. Fun fact, there's like no consensus about why the linker flag is called LD. There's two main theories. That one is that it stands for loader, and the other stands for link editor. And no one knows, and it's just lost to the past. So if you put everything together, You get these C files and A header files. They get compiled into object files. You put them together with any libraries that you want to use. And then you put them through a linker. Then you get the bundle. And this is a very complex process. There's a lot of things that you will need to configure. So what's happened in historically, and the main way that these places get automated is that you put all of this and you have a make file that will centralize all the configuration that you need for this whole process. So back to our native extension, this is what we saw. And if I draw a line here, you can see that on the left side, there's Ruby. On the right side, there's C stuff. And the link that's really important is this xconf.rb here. So xconf.rb is a file that makes the make file that will be used for everything else. And of course, there's a library in, there's a gem or the standard library piece, and it's called Makefile. And it's exactly what it sounds like. It's a DSL, because Ruby loves DSL, to make Makefiles. So this is what a Makefile looks like. DSL, it has things like have library, have header, checking for, all the expressiveness we love from Ruby. And then I looked at that file, and it looked very familiar. Then I realized this is my error file. This is my login error. And you can see a one-to-one match between the xconf.rb and the errors that are output by gem install. Have library, no library. Have header, no header. Checking for libexif, nope. Yeah. So now we start to understand a little bit where this thing comes from. So what we know so far is that the xconf.rb through Makefile cannot find the libexif library. And now we are looking for two files that the xconf.rb file really needs to work with, that it was looking for. So we have exifdata.h and libexif.dylib. dylib is dynamically linked library. It's just a library in macOS. That's the extension. So it leaves us with two questions. One, where are those files in our system? And two, how can we make Makefile, that's three makes, find them? So let's go for detective time. First, we look for the files. Brew install libexif. That's the first thing I've done this before, so I'll do this. It shows that it's already installed. So it's not that I didn't install it, there's something else. So Brew gives us some tools to find out where these things get installed. So you can type brew info, libexif, and then it shows some information about it, and especially it shows here, it tells you exactly where those files are installed. So we follow the trail there. What's in this folder? So we check the files there. There's regular, some folder structure. Then we have this includes folder here. What's in there? A bunch of header files. So maybe we're on the right path. And here, that's the file we were looking for. So the file we're looking for is in the library path and include. And then there's this lib. We were looking for library, so lib sounds familiar. We check what's in there. And there it is. So we do find this dylib file that we were looking for. Then there's this package config thing. I don't know what it is. I'll put a pin on that, and we'll come back to it. So we found them. We found the files we wanted. They're here. But there's some issues with this. So first, you see that it's dependent on where Homebrew installs things. So maybe you can configure where Homebrew installs things. It's different on M1 Macs and Intel Macs. And also, it's dependent on the exact version of libexif. So if I were to hard code this somewhere, it would be very fragile, and it's like it would break at every update, or like with my colleagues who have older Intel Macs, it would break. So brew gives us a tool to go around that. There's this command called brew prefix that will actually output a symlink to exactly this. That doesn't have any version dependency, or because it's just a command that you can run, it will resolve the installation path for you. So we take, these are the paths we found, and we just replace the base path with this brew prefix. Sorry. So now we figured out where are these files in the system. The second step is how can we make this whole tool chain, the Makefile, find these. So we talked about these configuration flags that we can configure the compiler and the linker with. And basically, there's some flags that you can use to tell the compiler and the linker, go look there. So for the C flags, it's -I, capital I, which stands for include. So you can pass it -I and then the path to include. And there is no space there, which is very confusing, hard to read, but that's the way it is. And exactly the same thing for L, for LD flags. There's -L flag. L stands for library. And you can pass it a path for it to look in for extra libraries. So if you put all of this together, this is what we need to pass. So the C flags and LD flags with the brew prefix and the include and library. And how do we pass these environment variables to the C tool chain? The environment gets like manipulated so many times along the way that like you don't really have exact control of the environment. So what Ruby does, it provides us some helpers to interact with that. So we got this gem command flags, where we have --LD flags and --C flags, where you can use that to pass things to the Makefile toolchain. So we end up with this command, gem install exif --, and then -- again to pass the things to the underlying Makefile, and the two things. And this is the kind of stuff that you see on Stack Overflow, and you're like, I have no idea how they got to it. So that's the whole chain that comes into this. So if you do this, there you go. It worked. We did it. So what we did is like we first found the files that the extension needed by looking at the logs. Then we found out where the files were. We found out which compiler and linker flags do we need to pass them to all the way through. And then we passed them to the Ruby part so that the gem could be compiled. So if we go back to our questions, what's a native extension? Yes, we know now. Gems with native extensions are gems with C code that needs to be compiled. What does this error mean? The error meant that the gem had trouble finding exactly the library, and it needed some guidance to point to it. How can I fix this? Yeah, we just did. We pointed the library to the Makefile to the library files. We're using LD flags and C flags. Then why did it stop working? Like, I don't know. I still don't know why this worked on my old computer and I didn't have to do anything. Why did I like need to take care of this just on the new computer? And I still don't know. Also, like this is weird. Why do I need to specify the lib locations myself? Like why, the computer is good at automation, why can't it figure out these things by itself? Like if only there was a way to have your system know where the libraries are located, like some centralized place or something. So we had two pins, and let's go back to them. So the first one was when we looked at the library location. So this is where the library was installed. There's this folder called package config. And that name, I didn't know what that was, so I looked it up. Package config turns out, is a computer that defines and supports a unified interface for querying installed libraries for the purpose of compiling software. That sounds very familiar. And it's old, it's not recent. I'm not the first one to have that problem, and I'll give me the last one. So someone solved this already. And the way that they do this is that if you go to the libraries, so libraries can create a file called libexif.pc, and then this is the content of the file. And if you squint, you can see that it has like a libdir and includedir. So this is the things that we looked for manually. It even has the flags for the linker and the flags for the compilers that we have to do ourselves. And it even has this command, which is a magical command. It's like you run the package config --c flags --libs, the name of your library, and it outputs exactly the stuff that we just read it from scratch. This was my face after like 2 weekends of debugging. I was like, someone solved this problem, and I had no idea. And I look at xcomp.rb. That's where like the other pin that we had. There's a package config for libexif there. And I was like, yes, okay, so that must mean that if use package config to find the libraries, like why didn't it work? So I go back, brew info package config. You see the problem? So I give you, ladies and gentlemen, the one-liner. So after running this, you can run gem install, no flags, nothing. There you go. So the mystery solved. Like the reason that it worked on my old computer is that I had package config already installed. And the reason that I had that and I never had any idea is that it's declared as a dependency of many, many, many brew packages. So if you've had your computer for a while and you installed a bunch of brew packages, there's a very decent chance that you have package config already installed. And if you get a new computer, this should be one of the first things you do. So I want to finish up with some practical tips. First, a debugging cheat sheet. I want to finish with like some clear steps, what to do when you're running into this issue. So first, do I have a working C toolchain? And that's like the C compiler, C linker. If you get a really, really fresh computer, then it doesn't come with that. You have to run Xcode select. But that you only usually do that once per computer. 2, is there a library missing from my system? Whenever a gem is like needing a native extension and needs some library to be there, it usually says that in the README. So check the gems README, and it should give like one of the first things should be the information of the gems you need to install, or the libraries you need to install. 3, can Ruby find it? This is where most things go wrong. So like sometimes libraries are installed like in a non-standard way, or like they don't include this package config stuff. So sometimes Ruby needs some help to find where the library files are located. So when you have this error message, there's a list of flags that you can pass, and check for these flags and check if there's anything that you can use there. 4, is Ruby using the right version? So can Ruby find it? OpenSSL is hard to deal with sometimes. 5, like if none of these work, now we're getting into like some weird territory that you may have to start reading xcomp.rb and compare with the log output and see where things go wrong. And there's like weird thing with xcomp.rb that's a bit unexpected, is that when things are not found or like things are expected, by default it just continues going. And it's up to the gem programmer to make sure like to raise them. But by default it was just like continue going. So sometimes gem maintainers don't raise, or like they don't stop the execution, and you just continue going on, and like then it fails for something that hasn't been found way before. And last of it, if none of this works, it might be something that's like, you need to pass this like weird like flag because it's a new version of C or something. Usually go check into the GitHub issues, and someone has complained about this before. And for teams, like if you have teams that have to deal with this, there's like one tool that I want to give you is bundle config. So bundle config is a way where like you can set configuration flags like this, and it'll save them to a file that can be committed to the repo. And then you solve this once and for all for everyone in your team. So only one person has to go into the rabbit hole. And I want to say two things. If you're building a gem for that has a native extension, there's two things you can do to ease the pain of anyone who's downloading your gem. So the first one is precombined binaries. And this is where, for example, Nokogiri does that. If you look at a recent version of Nokogiri, you see that there's 10-ish versions, and each one is for a different architecture and platform. So what that means is that the maintainer of Nokogiri took the task on himself or themselves to compile the native extension for all platforms and all architectures. So it's a burden to take on as a maintainer, but this is the reason that no one had to struggle with Nokogiri for the last 7 years, and before that it was horrible. And another thing is, if you don't want to take all the burden of compiling everything for all the architectures, you can use package config. So if you have a native extension, you can add this line that we saw in libexif, and if the installer has the package config configured and installed, then it will just work, because in the DSL there's a way to abstract away this. So it's only this one line, but again, this is a way, like a thing that doesn't have a lot of, it's easy to forget about this, because when you do this, by definition, it works on your machine. So just don't forget about it, or like you know about it now. And if you find it missing, open a PR to a gem. This is a PR I opened to another gem with a native extension, and it's just adding this one line here. You don't see it very well from there, but you can add this one liner, and then it makes it very easy for anyone coming after you. So some parting thoughts. First of all, I still don't know why it's not installed by default with the Xcode command line tools or something, but I really think it should be part of the things you get without you knowing about them. 2, native extensions are a poorly known area for Rubyists. It's because we're in this like limbo between Ruby and you want to like do the work on your app, and the C place where like if you are a C developer, you know all of this. But the native extensions are a bridge between the two, and it's not knowledge that is accessible, like not accessible, but it's like not something that you need often, and it's not something that we know about very much. And this is one of the reasons why, because it's a very frustrating area to work on, because by definition, it happens during bundle install, and no one wakes up one day and says, I'm gonna do bundle install, and that's it. So like it's always in the way for you to actually do your work, and it's something that you just want to like solve and get done, and you're not really in the mindset or like in the right mind frame to be okay, I'm going to learn about this today. No, like you just want to get done with it. So yeah, this is what I did to my C extension. I could finally go back and work on my gallery. Now I changed it. The reason I wanted to make this change is that I wanted to make it so that instead of having one picture, I could have a slideshow that changed every 5 minutes. So now I have a working gallery where I can go from picture to picture like this. Thank you.